Okay, so now we move to the third chapter. So we'll start with section 1, motion in a straight line with variable force. Okay, so basically in chapter 1, you did learn about variable acceleration. So we learned how to deal with variable acceleration when acceleration was a function of time and when acceleration was a function of displacement. So over here, it's the same theory that we are going to improve by actually adding force into this. So basically, we are going to talk about variable force. The first one we will be discussing is force as a function of time and also force as a function of displacement. Okay, so look at this first part. So suppose the force is a function of time. So if the force is a function of time, so if the force is a function of time, what do we use? If you use force as a function of time, the acceleration you use, do you recall? There is a very specific format we use for the acceleration. So acceleration, if force is a function of time, it means acceleration is a function of time. So for acceleration, we use dv by dt. This is from chapter 1. Okay, so if we use the equation F equal ma, when we use the equation F equal ma, mass into acceleration, we use dv by dt. Are you guys with me? So force is a function of time. So we separate the variables. We bring the dt over here. Force into dt and here m times dv. And then both sides we integrate. Okay, here m is a constant. You can leave it out. So here both sides we integrate. Here your force is a function of time. So you have some variable here with respect to t. Okay. And over here, so this side you integrate with respect to t. This side you integrate with respect to v. So this is basically what you're going to do. Okay, so we'll go for the example. Also, just to give you a heads up, I think you can see over here what they have done. Also, suppose what if your force is a function of displacement? So look at this. If force is a function of displacement, then for acceleration, what do we use? Do you recall? If force is a function of displacement, then acceleration is a function of displacement. We use v dv by dx. Do you recall? If acceleration is a function of displacement, you must use acceleration is equal to v dv by dx. Agreed? So then you write here F equal ma. So force is a function of displacement. Acceleration you must use v dv by dx. And so F equals ma. For acceleration, you use m v dv by dx. And this time your force is a function of displacement. So here you get F times dx, mv times dv. And you integrate both sides. This is basically what we are going to do. This side here, your force is a function of displacement. So you have F in terms of x. So you could easily integrate that side with respect to x. The other side, you integrate here with respect to v. Okay, you will integrate with respect to v. So we will do some questions in the exercise. We'll move to the questions and see how it is applied. Okay, so moving on to exercise 3A, question number 1. A particle P of mass 0.2 kilogram is moving on the x-axis. At time t seconds, P is x meters from the origin O. The force acting on P has magnitude 2 cos t Newton and acts in the direction OP. Do you see what's happening here? So you have a particle of mass 0.2 kilogram. Let's note down everything. The mass is 0.2 kilogram. The force acting on P has magnitude 2 cos t Newton. So the moment you look at this, your force, you can see it's definitely not a constant force, it's a variable force. And over here, your force is a function of time, cos t. So cos t means your force is a function of time. And acts in the direction OP. OP means it's acting away from the origin, isn't it? So if your force is acting away from the origin, we can use it as a positive figure. Okay. When t equals 0, so these are basically the boundary conditions. When t equals 0, particle is at rest means the velocity is 0. At O means x is 0. Basically, when at time 0, particle is at rest at the origin. So at time 0, velocity is 0 at x equals 0. Because origin means the displacement 0 position. Calculate the speed of P when t equals 2. How do you calculate the speed? Now they have given you the force. How do we come from the force to the speed? Obviously, what do? We have to first find the acceleration and then come to the speed. So how do we do this? We use here F equals ma. Just follow the steps that I did over here. I showed you some steps that we did over here. You just have to follow these steps. So over here, F equal ma, force is 2 cos t, which is positive. Mass is 0.2 kilogram. And what do we use for the acceleration? What do we use for the acceleration? When force is a function of time, acceleration must be, referring the note that I gave you, acceleration must be dv over dt. Acceleration must be dv over dt. So taking dt to the other side, 2 cos t dt equals 0.2 dv. So separate variable. And now what do? Now we integrate. So this side integrates with respect to t, the other side integrates with respect to v. And now it's time to go through the P3, P4 integration rules. Can I know the integration? What is the integration of cos? 2 times cos integration is? What is the integration of cos? Okay, so cos t integration is sin t. Do you see? So if it's cos x integration is sin x, cos t integration should be sin t. So 2 times sin t equals 0.2 is a constant. Here you integrate with respect to v. So when you integrate just with respect to v, it should be v. Do you recall? Just the one that you integrate with respect to v, it gives you v. And don't forget to use the plus c. Once you integrate, you must use plus c, isn't it? Okay, now how do we find the c? You have to find the c value. To find the c value, you have to go for the boundary conditions. What are the boundary conditions? At time 0, velocity is 0. They've given you at time 0, velocity is 0. Use it. At t0, x is 0. Get the c value. 2 sine 0, 0.2 into 0 plus c. 2 times sine 0 is 0, 0.2 into 0 is 0 plus c. So you can see c actually becomes 0. Okay, so then input that value back into the main equation. 2 sine t equals 0.2 v plus c is actually 0. Okay, so 0.2 is actually 1 over 5, right? So v equals 10 sine t. So velocity is equal to 10 sine t. So what do they want us to find? Find the speed of p when t equals to. So when t equals to, how do you get the speed? V equals 10 times sine 2. Basically, speed means they just want the magnitude, the size of it. Okay. So what do you get here? 10 into sine 2. Make sure you need to try this in the calc. Make sure the calculator is in. Make sure the calculator is in radian mode. You are inputting a time value into a sine function. So when you input time values into sine cos functions, your calculator must be in radian mode. So 10 times sine 2. We'll get the answer 9.092. So there's a long answer that comes, right? 9.092. So 3SF 9.09 meters per second corrected to 3SF. Then the next one, they ask us to find the speed of P when t equals 3. So part B, when t equals 3, is it difficult? The speed when t equals 3, all you got to do is substitute the t value as 3. So we got the V equation, V equal 10 sine t. So t is 3. Substitute the, just type the value in the cal, 10 times sine 3. So you get the answer, V equal 1.411. So correct to 3SF, V equal 1.41 meters per second. Moving on to part C, they ask you to find the time when P first comes to instantaneous rest. So how do you find the time it first comes to instantaneous rest? Basically, the velocity becomes 0. I think we can see the velocity is 0 at time 0 also at the beginning, but that's not the time. They want the next time. Then the very next time, after time 0 where the velocity is 0. So let's go to the velocity equation. You can see clearly I have the velocity equation. Velocity is 10 sine t. When you come to instantaneous rest, velocity is 0. So 10 sine t equals 0, which means sine t equals 0 divided by 10 is 0. So basically you need to find the t value is sine inverse of 0. So just remember the graph, sine graph. Every place where the sine graph becomes 0. What are they? Starting 0, pi, 2 pi, isn't it? Yeah, so the first t value other than 0, you can see it goes on. The first t value other than at the beginning, the t value we require here is pi. Okay, so the very first t value that we require here is t equal pi seconds. Okay. Part C, they ask you to find the distance of OP when t equal to. So distance OP. How do we get the distance when t equal to? So basically distance means I need to get this velocity. I have to further integrate it. But so what do we know about velocity? We do know velocity is equal to dx by dt. This is something that you can always use anywhere. Velocity is dx by dt. So it's there's nothing here to like separate for displacement and time, because you can see it's with respect to displacement and with respect to time. So velocity is dx by dt. So unlike acceleration, you don't have two equations for it. So velocity equals to 10 sine t. Replace the velocity with dx by dt equals 10 sine t. Now what do we do? Separate variables. So dx equals 10 sine t into dt. Agreed? I took the dt to the other side, and then let's integrate. Can I know the integration? This side you integrate 1 with respect to x. So you get x. On the other side 10 sine t. So what happens when you integrate sine? Sine integration 10 times sine integration is minus cos t. Minus cos t. And don't forget the plus c. Okay, so in this case, don't use c because we used c previously also, right? Shall we use a different constant? Plus k. So x equals minus 10 cos t plus k. I'm using k for the arbitrary constant because we used c previously. Okay, now the task is to find the integration is done. Task is to find the arbitrary constant. How do you find the arbitrary constant? We have the initial conditions. What are initial conditions? At time 0, velocity is 0, x is 0. These are the boundary conditions that we can use to find any of these constants. So at time 0, you can use x is 0 here. So 0 minus 10 into cos 0 plus k. Guys, over here, does this become 0? No, right? I think you can see cos 0 is actually 1. So this becomes minus 10 plus k, which gives me k equals plus 10. So therefore, I can write my the displacement equation x equals minus 10 cos t plus 10. So this is the k value. X equals minus 10 cos t plus 10. I'm supposed to find what? The distance at time 2, right? So let's get that time 2. At t equal to, make sure the calculator is in radian mode. Can I know the answer? Ten times cos 2 plus 10. How much is it? Oh, sorry, minus 10. Over here it's a minus 10, right? It's minus 10 cos 2. 14.1614, which means corrected to 3SF. 14.2 meters corrected to 3SF. Okay. And the last part, they want you to find the distance OP when P first comes to instantaneous rest. So they want you to find the distance OP when P first comes to instantaneous rest. So where do we first come to instantaneous rest? Didn't we find it? We found it first comes to instantaneous rest at t equals. We found that it first comes to instantaneous rest at t equal pi. Didn't we find this in part C? Didn't we find it in part C? The it first comes to instantaneous rest when t equal pi. So the time taken to first come to instantaneous rest is when t equal pi. You are supposed to find the distance. So x equals minus 10 cos t plus 10, right? X equal minus 10 cos t plus 10 is the equation. Replace t with pi. How much is the answer? Cos pi, I believe, is minus 1. Minus 10 into minus 1 is plus 10 and plus 10. So you get here x is 20 meters. Okay. Okay, question number 2. A van of mass 1200 kilogram moves along horizontal straight road. At time t seconds, the resultant force acting on the car has magnitude 60,000 over t plus 5 square newtons and acts in a direction of motion of the van. Okay, so when t equals 0, the van is at rest. The speed of the van approaches the limiting value v, meter per second. Find the value of v. Okay, let's do this. Okay, so first thing they give you is they give you the force. The resultant force acting on the car is 60,000 over t plus 5 square newtons. The mass is 1200 kilograms. Okay, at time t seconds, the resultant force acting on the car has magnitude, okay, and acts in direction of motion of the van. Okay, so at time 0, the van is at rest, which means velocity is 0. The speed of the van approaches the limiting value v. Find the value of v. Okay. So what do we use here? We will be using F equal ma. Anyway, to find the speed, I have to get the v value. So for acceleration, we will use what? Since force is a function of time, we will use dv by dt. We will use dv by dt. So the force is 60,000 over t plus 5 square dt equals m times dv. The mass is actually given to us, right? Mass is 1200. And so now let's integrate both the sides. So this side integrates with respect to v, this other side integrates with respect to v. Take the constant out. Taking the constant out, you get here 60,000 integration with t plus 5 to the power minus 2. dt equals, on the other side we have 1200 is a constant. Take it out, and inside the integral sign you have just 1. You integrate with respect to v. So 60,000, when you integrate t plus 5 to the power minus 2, you add 1, t plus 5 to the power minus 1, divide by minus 1. There is no coefficient of t. If there was a coefficient of t, we would have to divide by that as well. Okay, so this is equal to 1200. The integration of 1 with respect to v is v plus the integration constant c. So let's rearrange. This is minus 60,000 into t plus 5 to the power minus 1 equals 1200 v plus c. Substitute when t equals 0, v equals 0. When t equals 0, v equals 0. Minus 60,000 into 0 plus 5 to the power minus 1. 1200 into 0 plus c. Can I know how much this is? Minus 60,000 into 5 to the power minus 1. Basically minus 60,000 into 1 over 5, right? How much is it? 1200 into 0 is 0 plus c. So minus 60,000 into 1 over 5 minus 12,000. This is okay. Okay, so we get here okay, and then let's input the values. back to the main equation. So I get here the main equation, substitute back to the main equation. Okay, so go back to the main equation. Minus 60,000. P plus 5 to the power minus 1 equals 1200 V plus C. C is minus 12,000. Minus 60,000 over T plus 5 to the power 1. Minus 1 becomes plus 1. 1200 V minus 12,000. I'll bring it to the, we'll bring it in the next step. But you can see here, I can definitely cut out, divide by 1,000, right? No, sorry, I can divide by 100. The whole equation I can divide by 100, isn't it? Do you see? Also, we could divide the whole equation by a 12. Can you divide 600 by 12? What do we get? Divide the whole equation also by 12. How much is it? 50. So minus 50 over T plus 5 equals 12. V divide by 12, that's V. 120 when you divide by 12, that's 10. So you get here minus 50 over T plus 5 minus 10 comes as plus 10 equals to V. Agreed? Equals to V. So this is the velocity equation. Okay, so this is our velocity equation. Now they are asking us to find the limiting value of the velocity, right? So limiting value of the velocity in the sense, now if you consider this particular graph, this particular velocity time graph, you do realize this T plus 5 is actually, you can see that it is actually, how do we say, we kind of have a limiting value here in the sense you can have an asymptote here, right? So for instance, do you recall in P1, if when x tends to infinity, do you recall 1 over x tends to 0? Are you familiar with this rule? So in the 1 over x graph, so this is the 1 over x graph. So when x tends to infinity, when x gets really large, 1 over x gets closer and closer to 0. Right? Okay, so we could use a similar strategy here to get the limiting value of t. Okay, so you can see here we have t in the denominator. So when t tends to infinity, what do you think happens here? 1 over t plus 5. So it doesn't matter even if you have t plus 5. It will become 0. Okay, because 1 over following this rule, it doesn't matter even if you have a x plus a or any constant in the denominator. Okay, so basically minus 50 over t plus 5 will immediately tend to 0. This immediately tends to 0. So when t tends to infinity, what do you get here? Your velocity is 10. The limiting value of the velocity is 10 meters per second. This is how you get the limiting value of the velocity. Part B, they ask you to find the distance moved by the van in the first 4 seconds of its motion. Okay, so first to get the distance that you're moving in the first 4 seconds, what do you have to do? You need to get the distance, displacement equation, right? So we just found that velocity equals minus 50 over t plus 5 plus 10, right? So what's the first thing we do? First thing you do is replace the velocity with what? Dx by dt. Velocity is dx by dt equals minus 50 over t plus 5 plus 10. And now you can separate variables. This side you can keep dx weighting. Minus 50 over t plus 5 stays here plus 10. So this side you get with respect to t. And then you integrate both the sides. The first side integrates with respect to x. This side integrates with respect to t. So when you integrate with respect to x, over here you get x. Minus 50 over, and when you integrate 1 over t plus 5, it will be ln t plus 5, right? 1 over x integration is ln x. So 1 over t plus 5, integration ln t plus 5. Just integration of 10 is 10t. Okay, and then don't forget the plus c. Okay, so how do we find the c value over here? Actually, to find a C value, you might be reading through the question, and I think you might notice that they have not specifically mentioned about any displacement positions here, right? Have they? I think they have not told you at time zero, the van is at rest. That's all they've given you. But also what we do know here is this van is approaching a limiting value of it. It's moving completely forward, isn't it? It's moving completely forward and they have not, and you do realize it's not having any movement where it's coming back and again going front. So you don't have such a movement. In that case, what you can do here is you can take the starting point wherever it starts because it doesn't come back there. The place where you started, you can consider it as a displacement zero position because they have not specifically mentioned any other point to be used here. Okay, so since it's going completely forward and there is no confusion here as well, we can easily go wherever the place that we started. We are going to measure our displacement from that point. Okay, so we'll be measuring our displacement from that point. So I will be using here when t equals 0, x is 0. What do we get here? When t equals 0, x is 0. So I get here 0 equals minus 50 ln 0 plus 5. 10 times 0 is 0 plus c. So I get here minus 50 ln 5 plus c. So we get here c equals minus 50 ln 5 comes to the side as plus 50 ln 5. So basically I got the c value of the, I could have used this as k, right? No, we never, did we use c previously in the question? Yeah, we used c previously. Okay. So we could have used this as k or, a different constant. Anyway, it's fine. So the x equation is minus 50 ln t plus 5 plus 10t and the c value is 50 ln 5. Agreed? Okay, so what are we supposed to do now? They're asking us to find the distance it moved in the first 4 seconds. So when t equals 4, replace t with 4 minus 50 ln 4 plus 5 plus 10 times 4 plus 50 ln 5. Shall we first get the exact answer? Minus 50 ln 9 plus 40 plus 50 ln 5. So we'll take the log terms close to each other. I'll bring the log terms close to each other. Taking 50 out, I get here ln 5 minus ln 9. Guys, do you agree? Because this is positive, I wrote it first, and minus ln 9. So logarithms, when there's a subtraction, you can write it as a division under a single logarithm. 50 ln 5 over 9 plus 40. So this is the exact distance. Most of the time, they would expect you to give the answer in exact form. If they do want it to 3SF, you can give it to 3SF. But most of the time, they would probably ask you to give the answer in exact form. So 50 ln 5 over 9 plus 40. Answer is 10.6. So if it's to 3SF, 10.6 meters correct to 3SF in the first 4 seconds. Okay, so exact answer would be, definitely, it depends on the question. Most of the time, they would ask you to give the answer in exact form. Okay, moving on to question number 4. A particle P of mass 0.75 kilogram is moving in a straight line. At time t seconds after it passes through a fixed point on the line O, the distance OP is x meters and the force acting on P has magnitude 2e to the power minus x plus 2 newton and acts in the direction OP, which means it's acting away from the origin. Okay, so force is 2e to the power minus x plus 2. Given that P passes through O with speed 5 meters per second. So basically they are giving you the boundary conditions. So they say at time t seconds, they say here, given that P passes through O, so when x equals 0, the speed is 5, velocity is 5. Calculate the speed of P when x equals 3. Okay, so how do we get the value of x equals 3? So first thing we should do here is, let's go for the equation. We have to get the speed equation, the velocity, and then we'll go for the displacement. So what do we get here? F equal ma. So force is 2e to the power minus x plus 2. If your force is a function of displacement, then acceleration, what do we use here? Do we use dv? What is the correct equation? Can we use dv over dt? No, dv over dt is only for when it's a function of time. If it's a function of displacement, the specific value we use is v dv by dx. Okay, when acceleration is a function of displacement, we use v dv by dx. Okay, we did this in the first chapter as well. Is the mass given to us? Yes, mass is 0.75 kilograms. Okay, so now it's time to separate variables and integrate. So 2e to the power x minus x plus 2, you take dx over here. Over here, you have 0.75 into v dv. So we integrate, I kept the constant out. Okay, let's integrate 2e to the power x. When we integrate, it's 2. So when we integrate over here, we get 2e to the power minus 6 divided by minus 1 plus 2x. Plus 2x equals 0.75. V, when you integrate with respect to v, it's v square over 2. You add 1 to the power and divide, isn't it? And you put plus c. So when you rearrange, it's minus 2e minus x plus 2x. 0.75 over 2. 0.75 is 3 over 4. 3 over 4 into half is 3 over 8 v square plus c. Agreed? Let's get the c value. So when x equals 0, v equals 5. When x equals 0, v equals 5. So you get here 2 minus 2e to the power 0 plus 0 equals 3 over 8 into 5 square plus c. So 2e to the power 0, any number to the power of 0 is actually a 1. So you get here minus 2. 3 over 8 into 5 square, that's 25 into 3, that's 75 over 8. Can I know the c value? Minus 2 minus 75 over 8 gives me c as minus 91 over 8. Okay, agreed. Input the c value back into the main equation. Minus 2e minus 6 plus 2x equals 3 over 8 v square. C is minus 91 over 8. Okay, so make v square the subject properly. So I get here minus 2e minus 6 plus 2x plus 91 over 8 equals 3 over 8 v square. Agreed? So let's multiply the whole thing with 8 minus 16e minus 6. 8 times 2 16x. 91 over 8 into 8 is 91. And then you can divide the whole thing by 3. So minus 16 over 3e minus 6 plus 16 over 3x plus 91 over 3. So whole thing divided by 3. So this is the v square equation. Do you agree with me? Okay, so the question they're asking us to find the speed when x is 3 and when x is 7. So part A, when x is 3, v square equal minus 16 over 3 e to the power minus 3 plus 16 over 3 into 3 plus 91 over 3. Can I know the answer? V square. So you type the whole thing in the cal and then you square root it. How much is it? So the v square value when you type in the cal, it's going to be 46.0067. It goes on. So let's square root that answer directly and let's get the answer. V equals square root of that answer. So directly go for this in the cal and you get How much? 6.78787, so which means 6.79 meters per second corrected to 3SF. That's part A. Part B, I think they want you to find the velocity when the speed when x is 7. Right? So when x is 7, can I have the speed? V square equal minus 16 over 3 e to the power minus 1. Basically replacing all the x values with 7. Plus 16 over 3 into 7 plus 91 over 3. How much is it? Type this value in the calc, get the root. 16 over minus 16 over 3 into e to the power minus 7 plus 16 over 3 into 7 plus 91 over 3. Oh no, I think I've made it minus 16 over 3 into e to the power minus 7 plus over here, right? Plus 16 over 3 into 7 plus 91 over 3. And I get 67.66. So let's, that is V square root the answer. And we get 8.225. So correct to 3 is 8.23 meters per second. Okay, so then let's move to the last part. Part C, they ask you, calculate the work done by the force in moving the particle from the point where x equals 3 to the point where x equals 7. So part C, they want to calculate the work done by the force. Okay, so work done by the force. How do we actually calculate the work done by the force? So normally we say work done. We normally say work done is equal to change in energy, right? So work done equals to change in energy. In this case, you have kinetic energy, right? In this case, you have kinetic energy. So basically, you could get the, how do we say it? You could get the change in energy, or else let me show you. You could basically get the half mv square minus half mu square at x equals 7 and x equals 3, right? Or else, just to show you how this actually works, okay, just to show you how this actually works, when your force is a function of displacement, you get here mv dv by dx, right? When you use f equal ma, just to prove to you what's going on, f equal mv dv by dx, this is what we did at the very beginning, isn't it? Over here, this is what we did over here. Do you recall? F equal ma. So if force is a function of displacement, F equal m v dv by dx. So over here, if you carry this forward a little bit, if you take this a little bit forward, and let's use the integration limits. Now, what are our limits? The starting velocity is u, and the ending velocity, I'm using it as v. Are you with me? So what do I get here? Integration of the force with respect to x equals m. When you integrate v with respect to v, what do you get? When you integrate v with respect to v, you get v square over 2. Agreed? You add 1 to the power and divide v square over 2. And you can see after integration, I'm going to use the integration limits. So that when you use integration limits, you don't have the plus c. Where do I get these limits? The limits are from, now you know you are integrating with respect to v. So I'm using the v limits, the starting velocity u and the ending velocity v. Okay, so over here, I think you can see this when I input the limits over here. What do we see here? M, first replacing the v with v, that makes no difference. Mv square over 2 minus the next one is mu square over 2. Guys, do you see what this is? Half mv square minus half mu square. Who is half mv square minus half mu square? That's the change in the kinetic energy. These all the objects that we are working with in this particular exercise, they are moving on a straight road. So basically, change in kinetic energy would give you what? Change in kinetic energy. So when you integrate the force with respect to x, you get the change in kinetic energy. Change in kinetic energy is what we also call as the work done. Work done by the force is equal to change in kinetic energy. This is that is the main equation. That is change in work done equals change in K if you're moving on a horizontal surface. Okay. So over here we have everything moving on a horizontal surface. So this is the equation. Work done equals to change in Ke, which is equal to integration of f with respect to x. However, to do this, your force must be a function of displacement. Your force must be a function of displacement in order to do this. So we will go with that. I have done the proof now. So I will directly write here work done equals integration of the force with respect to x. And what are our x limits? Yeah, x limits are from 3 to 7, right? They want the work done from x equals 3 to x equals 7. So our force was 2e to the power minus x plus 2, right? That was our force, isn't it? The force was 2e to the power minus x plus 2. Yeah. So then let's integrate and put the limit. So this is 2e to the power minus x divided by minus 1 plus 2x. Integral limits 3 to 7. So this is minus 2 e to the power minus 7. 2 times 7 is 40. Now you guys following me? I just put the minus on top here. Minus 2 e to the power minus 7. 2 times 7 is 14. Minus 2 e to the power minus 3. 2 times 3, that's a 6. Minus 2 e to the power minus 7 plus 14. Minus into minus is plus. 2 e to the power minus 3. Minus into plus is minus 6. So over here we get minus 2 e to the power minus 7 plus 2 e to the power minus 3. 14 minus 6 is, that's 8, right? So now you can type the whole thing in the cal to actually get the work done. So 8.0977, correct to 3SF, 8.10 joules. 8.10 joules. Okay. Okay, so the one more thing over here, I think you saw that I integrated this function force as a function of displacement further to see when your force is a function of displacement. When you integrate the force, you can actually get the work done. Similar to that, if you also do force as a function of time, if you continue this further, okay, so force when you integrate, and over here you are integrating with respect to v. Let's say the v limits are u and v, our velocity limits. Force is a function of time, so it's going to be there. That's an unknown. Force is a function of time, m. When you integrate 1 with respect to v, it's v. And your integration limits are from u to v. Okay, so what do you get here? Force as a function of displacement. You get here, so you replace the v first with v, then you replace it with u, isn't it? Same, you get here v minus u. You replace the first limit with v, the next one with u. So what is this? If force when you integrate with respect to t, you get here mv minus mu. So who is mv minus mu? If you recall m1, mv minus mu is the impulse. Okay, so mv minus mu is the impulse. Change in momentum equals to impulse. Okay, so impulse equals, so if you have a force with respect to time and if you integrate the force with respect to t, with the t limits, you will be able to get the impulse. If you have a force with respect to displacement and if you integrate that force with the displacement limits, you will be able to get the work done by the force. The other one will give you the impulse provided by the force. So these are some basic things that you should know. Okay.